Hello, in chapter 6.6 we're going to be looking at inverse trigonometric functions. So the first function that we'll focus on is the inverse of the sine function. So in order to define the inverse of the sine function, we first need to specify an interval on which the sine function is 1 to 1. Because clearly if we look at the graph of the sine function over the whole real line, we notice it is certainly not 1 to 1. For instance, if I draw this horizontal line, it passes through the graph of sine at many different points. So the conventional way to restrict the domain for sine is to just do the interval from negative pi over 2 to positive pi over 2. So we're going to chop the graph of sine x at those 2 points, and then just focus on that portion of the graph to make it 1 to 1. So here we're going to restrict it to the interval from negative pi over 2 to positive pi over 2 when we're defining the inverse of sine. So the way that we're going to define the inverse is like any inverse function. We say that sine inverse of x equals y if and only if x equals to sine of y, with the restriction that y is always going to be a value between negative pi over 2 and positive pi over 2. We know that without this restriction there could be potentially many answers, so we want to make sure we're specifying one specific answer for a particular inverse value. And by the way that we've defined it as well, we know that since the sine function is always between negative 1 and positive 1 as the output, the input values for sine the input values for sine inverse will be between negative 1 and positive 1. So we know the input values for sine inverse, will be between negative 1 and positive 1, and the output values will be between negative pi over 2 and positive pi over 2. Arc sine is another way of writing sine inverse. So you may see these two notations used interchangeably. And in fact, this notation may be reminiscent of how the angle is related to a point on a unit circle. So, for instance, if I am thinking of the angle theta, we oftentimes think of that as the arc of our unit circle. And so arc sine would be referencing that angle that it creates when it forms the point on the unit circle. Anyways, so let's just try out a couple of different examples. The inverse sine of 1/2. Here we want to think of a value such that the sine of that value is equal to 1/2. Right. And in this case, it might be helpful to just remember some basic points on our unit circle. For me, it helps to just remember the basic, so we know going from negative pi over 2 to positive pi over 2 here in our first and fourth quadrant. It's helpful to remember the basic points here. So we're looking for the one that has a y value of 1/2. And the way I remember that's going to be the shorter of the angles that are in the first quadrant there. So that's going to be the angle pi over 6 that has a sine value of 1/2. Because remember, the coordinates of that point there will be radical 3 over 2 for the x coordinate and 1/2 for the y coordinate. Okay, how about composition of the form tangent of arc sine of 1/3? Well, here I'm going to do a little bit of triangle geometry, because that'll actually help me think about how the arc sine relates to an angle in a right triangle. So let's call this angle theta. Let theta equal to arc sine of 1/3. And what that really means is, because this is sine inverse of 1/3, it means that sine of theta is equal to 1/3. So what helps is we can imagine a triangle, a right triangle, where the angle theta is the angle that we're associating with arc sine of 1/3. And so the opposite over the hypotenuse of that triangle will be 1 and 3. Because we know that the sine ratio is going to be the opposite over the hypotenuse. And so to find the third side that we're missing in the right triangle, we can use the little Pythagorean theorem. And let's see, in this case it would be, I think, the square root of 8. Okay, you can double check that here. Square root of 8 squared plus 1 squared equals 3 squared, right? So we were just basically solving this Pythagorean theorem equation there. So that gives us the missing side here. So 1 plus 9, or sorry, x squared plus 1 equals 9, so 9 minus 1 is 8. So x is the square root of 8. Now with that, we can come back to our original problem, which is we're really trying to find the tangent of that angle, theta, which is going to be the opposite over the adjacent side. So we'll do 1 over the square root of 8. So here's an important property that we can inherit for the inverse sine. Remember, this is true for any inverse functions. But here we're saying that sine inverse of sine x is equal to x. But in this case, remember, we have to specify what the domain would be where this is true. In this case, from negative pi over 2 to positive pi over 2, this will be true. And then sine of sine inverse of x will equal to x, but only for values of x that are between negative 1 and positive 1. So just to kind of think of how this might be an important thing to consider, suppose I have sine inverse of sine of 3 pi over 4. So in this case, 3 pi over 4 is actually bigger than pi over 2. So it's not in that range between negative pi over 2 and positive pi over 2. So in other words, what we're really looking for is an angle that has the same value as, that has the same sine value as 3 pi over 4, but which lies in the first or the fourth quadrant. And in this case, it would be pi over 4. Right, because actually one way I can think of it is I know that sine of 3 pi over 4 is equal to radical 2 over 2. And so sine inverse of radical 2 over 2 must be an angle in quadrant 1. So that's how I get pi over 4. Similarly, if I have sine inverse of 1.5. Well, sine inverse of 1.5 doesn't exist. Remember that this is not in the domain of our sine function, or of our sine inverse function. So sine inverse 1.5 is not a defined value. So this is not a number. On the other hand, suppose I have sine inverse of pi over 3. I'm sorry, sine inverse of sine of pi over 3. Well, pi over 3 is in the range from negative pi over 2 to positive pi over 2, so this is just going to be pi over 3. Or if I have sine of sine inverse of 3/4, this would have to be 3/4, because that's in the range from -1 to 1.